solve this triangle right here. All right, solve the triangle means find all the other missing parts. What do I have? Two angles, a side, nothing else. So whenever I have two angles, first thing that I can do is I can find that missing angle by doing 180 minus 113 minus 36, and that gives me an angle measurement of 31 degrees. So angle P is 31 degrees. I meant to say angle P is 31 degrees, not angle 31 degrees. Let me just write that out. So many mistakes. All right, now what do we have? Well, we have all three angles. This side opposes this side. And I don't know, if I were to choose, doesn't really matter, K, then what I can do is I can set up the law of cosines. Now, what the law of cosines says, and let me use P, what did I say, P and K? The law of cosines says that if I take the sine of, what do I know now, P over its opposite side, little p, that's going to equal the sine of big K over little k. Whenever you have two pairs rather, and you have three pieces of that information, the law of sines is definitely going to be your guy. All right, so let's plug it in and see what I get. Sine of P means sine of 31 degrees over little p, which is 14. Remember, little p is the opposing side. That's going to equal sine of K, which I know to be 36 degrees, over its opposite side, so we'll call that K, little k. Whenever you have a fraction equaling a fraction, crisscross applesauce, so 14 times sine 36 is going to be 14 sine 36 degrees, is going to equal K times sine 31. Okay, if you just want to do this all in one shot and right now divide both sides by sine 31, that crosses out and leaves K all by itself. And so I could just type 14 sine 36 over sine 31 straight into the calculator, and that gives me K equaling 15.9774. So you are 15.977. So I got two sides, all three angles. I still need this little h. That's not called little h, but little h over here. So what I can do is I could use this same exact information over here, but replace the k's with the h's. If you're like, well, why not Pythagorean theorem? This isn't a right triangle. Can't use Pythagorean theorem. So I'm going to use sine big P over little p again and replace the k's with h's. Sine big H over little h. So sine 31 again over 14 is going to equal sine of, what do I have, 113 over little h. Crisscross applesauce. When I do that, that gives me 14 sine 113 degrees this time equals h times sine 31. If we want to throw all of this into a calculator, let's divide both sides by sine 31. Divide both sides by sine 31. That crosses out everything, leaving h on its own. And according to a calculator, which I used ahead of time, h is going to equal 25.0216. So 25.0216. There you have it. So 31 degrees, 36 degrees, 113, 14, something that's awfully close to 16, and something that's awfully close to 25. I did it. I solved the triangle.